Welcome to today's ArXiv CS Digest for April 6th, 2026. We received 540 new computer science papers today across 57 subfields. Let's dive into the top picks. Trend 1 of 5, Advanced 3D Gaussian Reconstruction. These papers advance 3D and 4D scene reconstruction, understanding, and generation using innovative Gaussian-based representations. This cluster covers 24 papers. Representative work includes weakly convex ridge regularization for 3D non-Cartesian MRI reconstruction, shelf Gaussian, shelf-supervised open vocabulary Gaussian-based 3D scene understanding, and free-range Gaussians, non-grid-aligned generative 3D Gaussian reconstruction. Trend 2 of 5, Foundational Algorithms and Problem Solving. This trend explores fundamental algorithms and theoretical frameworks to solve diverse, complex computational and real-world problems. This cluster covers 105 papers. Representative work includes comprehensive list of user deception techniques in emails, dominating set with quotas, balancing coverage and constraints, and demonstrating SEMA play, a serious game for forest management decision-making through board game and digital simulation. Trend 3 of 5, Large Model Reasoning and Efficiency. This trend advances large model reasoning and efficiency, tackling challenges in their practical application, deployment, and interpretability. This cluster covers 192 papers. Representative work includes Beyond the Final Actor, modeling the dual roles of creator and editor for fine-grained LLM-generated text detection, early stopping for large reasoning models via confidence dynamics, and rethinking model efficiency, multi-agent inference with large models. Trend 4 of 5, 3D Vision and Generative Models. Unifying 3D vision and generative models. These papers advance scene understanding, synthesis, and manipulation, often through synthetic data generation. This cluster covers 124 papers. Representative work includes VANIST, virtual try-on with human image animation via synthetic triplet supervision, point TPA, dynamic network parameter adaptation for 3D scene understanding, and LOMA, local feature matching revisited. Trend 5 of 5, Predictive AI for Dynamic Systems. This trend applies predictive AI to model, understand, and manage the complex evolution of dynamic systems. This cluster covers 95 papers. Representative work includes stratifying reinforcement learning with signal temporal logic, PINs and PDE constrained optimal control problems, direct versus indirect methods, and general geospatial inference with a population dynamics foundation model. Up next, our first paper out of 5, Making Bias Non-Predictive, Training Robust LLM Reasoning via Reinforcement Learning by Qian Wang and Bingsheng He for National University of Singapore. Let's break down its key contributions. EIT is a novel reinforcement learning framework designed to make bias cues non-predictive of reward, enhancing LLM robustness. It aims to induce transferable epistemic independence, preventing models from relying on spurious correlations for reasoning. This strategy ensures bias signals are equally likely to support both correct and incorrect answers during training. It creates a challenging environment where models cannot reliably exploit bias for reward, fostering true independence. A specific reward mechanism penalizes models for following bias cues, regardless of outcome, without rewarding agreement with bias. This directly discourages reliance on spurious correlations, promoting robust, bias-independent reasoning. Up next, our second paper out of 5, Incompleteness of AI Safety Verification via Kolmogorov Complexity by Munawar Hassan from Michigan Technological University. Let's break down its key contributions. The paper formalizes AI policy compliance as a verification problem over encoded system behaviors. This foundational step establishes a precise mathematical framework for analyzing safety constraints and their verifiability within AI systems. It analyzes the formalized verification problem using Kolmogorov complexity, introducing an information theoretic perspective. This novel application provides a powerful tool to investigate the intrinsic limits of certifying AI system behaviors. The paper proves a significant incompleteness result. For any sound verifier, a complexity threshold exists beyond which true policy-compliant instances cannot be certified. This establishes a fundamental barrier to comprehensive AI safety verification. This work identifies an intrinsic information theoretic limitation of AI safety verification, independent of computational resources. It reveals that no finite formal verifier can certify all policy-compliant instances of arbitrary complexity. Up next, our third paper out of 5, GPU acceleration of TFHE-based high-precision nonlinear layers for encrypted LLM inference by Guozi Chun and Jie Zhang from Peking University. Let's break down its key contributions. This contribution introduces a GPU-optimized WPPBS method, integrating numerical algorithms to overcome the inherent precision limitations of native lookup tables for nonlinear functions. It significantly enhances the accuracy of encrypted computations. This involves developing high-precision and efficient implementations for critical nonlinear layers found in LLMs, such as GELU, Softmax, and LayerNorm. This enables practical and accurate encrypted inference for real-world applications. A novel batch-driven design is proposed to exploit inter-input parallelism, significantly boosting GPU efficiency during encrypted LLM inference. This optimizes resource utilization and accelerates overall processing speed. Up next, our fourth paper out of 5, Don't Waste Bits. Adaptive KV Cache Quantization for Lightweight On-Device LLMs by Syed Pedram Harry Borageni and Abolfazl Razi from Clemson University. Let's break down its key contributions. This component extracts lightweight token-level features such as token frequency, quality score, attention variance, and entropy-based uncertainty. These signals are crucial for assessing token importance, guiding the adaptive quantization process effectively. A compact, learned multilayer perceptron, MLP, acts as a data-driven controller. It processes the extracted token-level features to determine the optimal quantization bit width for each token dynamically. This policy dynamically assigns per token KV precision, 2-bit for bit, 8-bit, or FP16, during decoding based on the controller's output. It minimizes memory and latency by allocating bits proportional to token importance. Up next, our fifth paper out of 5, The Topology of Multimodal Fusion. Why Current Architectures Fail at Creative Cognition by Xiaojiang Tan from Guangzhou Academy of Fine Arts. Let's break down its key contributions. This framework integrates philosophical concepts, positioning Xiang as a crucial third state emerging from the intersection of saying and showing. It provides a foundational structure for understanding creative multimodal cognition. This conjecture proposes a topological opposition between overlap isomorphism, transversal coupling, and superimposition collapse, loss of transversality. It offers a precise falsification condition and a pathological mirror for the theory. The paper proposes a computational implementation path called UO, utilizing neural ordinary differential equations, nodes, with persistent homology, topological regularization. This enables practical modeling of the theoretical framework. The paper introduces the Analogy cross-modal analogy benchmark with a novel error-type ratio metric and the Metatop 3-tier benchmark. These evaluate cross-civilizational topological isomorphism.